Hey guys, welcome to your second video for Section 2, Chapter 6 of the Geometry program. In this section, we're just going to work on our proofs. So I wanted to have all of the theorems that you might need in one place with just a quick review, and then I'll work another example for you at the end. In order for you to be able to complete a proof, you have to know all of the theorems accessible to you. So just as a reminder, here are some types of angles that you might need to recognize in order to put your proofs together. Things like supplementary angles. Supplementary angles are also linear angles, right? They're going to add to 180. Remember, vertical angles share a vertex. They're opposite each other and they're congruent. Corresponding angles come when you have parallel lines cut by a transversal. They are congruent and they share the same position on the parallel lines. And then similarly, if you have same side interior angles are supplementary. So if they're inside the parallel lines and on the same side of the transversal. Okay, so those would be types of angles you need to familiarize yourself with if you don't have them already memorized. All right, other theorems we need to consider. So if you remember, we have an alternate interior angle theorem that says if we have lines that are parallel, cut by a transversal, then alternate interior angles are congruent. Meaning if they're on the inside of the parallel lines and on opposite sides of the transversal, then they're congruent. Well, there's also something called the reverse of the alternate interior angle theorem, which says if you can prove that these angles are congruent, then the lines must be parallel. Okay, so it goes the other way. So first we have, if we have parallel lines, then alternate interior angles. This one says if alternate interior angles, then parallel lines. Okay, so we can go both ways with this one. Similarly, we can do the same thing with same side interior and corresponding. If we can prove that 1 and 2 are corresponding angles, angle 1 and angle 2, are corresponding angles, then the lines must be parallel. Or if we can prove that angle 1 plus angle 3 are supplementary, then the lines must be parallel. Then parallel lines. So we've not said these things explicitly yet. We haven't really needed to use them, but now we're going to really expand our horizons in terms of our proofs and what we're going to use to prove things. So I wanted to make sure that we went through it. We have talked about midpoint, median, and angle bisector. So if you have a point that is considered a midpoint, then it splits the segment into two congruent parts. Same with a median, like if you had a line and another line went through it, and A is the median, it splits it into two congruent parts. And an angle bisector. If that ray is an angle bisector, then angle 1 is congruent to angle 2. So all of these three types of theorems are going to split things into two equal parts. Okay? The substitution property we haven't really seen yet, but you can probably figure out how this is going to go because your algebra is so good. For example, if we have something like the measure of angle 1 plus the measure of angle 3 equals 180 degrees, and we know that the measure of angle 2 is congruent to the measure of angle 3, then we can apply the substitution property. So the substitution property says if I have two things that are the same, then I can make a replacement, right? i.e. substitute. So I could write measure of angle 1 plus the measure of angle 3 equals 180, Or now I could write the measure of angle 1 plus the measure of angle 2 is equal to 180 by the substitution property. Okay, so it's a replacement. If you have two equal things, you can make the replacement. All right, next up, reflexive property should be your favorite property and mine, meaning AB is congruent to AB, or angle C is congruent to angle C. That's always a fun one. But we've not yet seen the transitive property. And the example that I'm going to do at the end of this video is going to involve the transitive property, because this one students oftentimes will confuse, and I want to make sure that you see how we're going to use it effectively. But this one says, if the measure of angle 1 is congruent to the measure of angle 2, and the measure of angle 2 is congruent to the measure of angle 3, then we can say that the measure of angle 1 is congruent to the measure of angle 3, right? So if A implies B and B implies C, then A implies C, okay? So you're going to see how that works practically in the proof that I'm going to do. But the other thing that we need to have like in your brain as we start to put together these proofs are all of our triangle congruence theorems. And those were the ones that were SSS, SAS, ASA, AAS, and also CPCTC. Remember, corresponding parts of congruent triangles are congruent. Okay, so hopefully you guys remember those. No, we've not lost them. All right, so let's dive in. Here is an example, a diagram for you, and it's given to us that A is parallel to B, that C is parallel to D, and that C and D are transversals to A and B respectively, right? So just saying clearly that they cut through them, all right? And we want to prove that the measure of angle 1 is congruent to the measure of angle 2. All right, so let's jump in. First off, we're always just going to use our given statements, right? So we're going to say that A is parallel to B and C is parallel to D, and the reason is going to be given. Then my second statement is going to be my second given statement, right? That C and D are transversals to A and B. This is also given. All right. Now, we need to have a plan before you can just start writing your proof, right? So if you look back at our diagram, I got to get from 1 to 2 using angle relationships of parallel lines. So, for example, if I notice angle 1 is congruent to angle 3 and they share the same positions, then I could say that they're corresponding angles. Then if you look up and see angle 3 is in the same position as angle 4 of the parallel lines, then those are also corresponding angles. And then finally, once I get to 4, I can notice that 4 and 2 have to be congruent because they're vertical angles. All right, and since I prove all of these congruent to each other, then we're going to use the transitive property that we just talked about. So that's where we're going. That's how we piece together a proof. You want to see what you need, what's congruent with what, and how we're able to give our reasons for that in order to be able to get going here. All right, so next step, number 3, I'm going to say that the measure of angle 1 is congruent to the measure of angle 3 because they're corresponding angles. All right. Then I can say that the measure of angle 3 is congruent to the measure of angle 4 because those are also corresponding angles. I had 2 sets of parallel lines, if you remember. So I can switch the rotation and notice that they're both sets of corresponding angles. All right, now I have measure of angle 1 congruent to 3 and 4 is congruent to 3. So now I can apply the transitive property and be able to say that the measure of angle 1 is congruent to the measure of angle 4 by the transitive property. Transitive. All right, almost there. Now I can say that the measure of angle 4 is congruent to the measure of angle 2 because they are vertical angles. And then finally, I can say that the measure of angle 1 is congruent to the measure of angle 2, again because of the transitive property. I proved that 1 was congruent to 4, and 4 was congruent to 2, so 1 has to be congruent to 2 by the transitive property. And that's it. Okay, there's only 4 proofs. They are not hard, so don't get overwhelmed. Just think about the pieces that you need to make your proof statement, and hopefully it'll come together for you. So go ahead and finish up your notes and begin your assignment.